iRaptor webinar series. Today's topic, Agile Development with ARM Embed OS. And, my name is Andreas, and during the next 30-35 minutes, I'd like to give a short introduction into developing firmware with ARM Embed OS and have a look at the Agile way of development with ARM Embed. So this webinar probably going to take 30-35 minutes, and it's going to be recorded. So you have the chance to look at it afterwards. After the webinars, we're going to send you an email with a link to our Knowledge Center where you can download and view the webinar and download the slides as well. Okay, so this is done using GoToMeeting. And you may have seen it as a chat window in GoToMeeting. We would like to do questions and answers through this chat window. So if you have any questions during the webinar, don't hesitate to type them, enter them into the chat, and I'm happy to answer that as good as I can. So let's get started. Bit about us. We're Think Forward. We're part of the Germany-based Cassini Group. It's a group of 270 IT specialists, and we're a small team within that group. And our topics are IoT in terms of architecture and implementation projects. We're doing training workshops, prototyping workshops, and developer workshops as well to get you on board with developing for IoT. And we're working on software products for agile IoT toolchains. The first one is iRaptor, which is a toolchain selector, so to say. Swift is a model-based approach to generating code for embedded, and Thinkstruction.online is another generator for Web of Things related API stuff. So that's about us. Today, this webinar and its objectives, I'd like to introduce to, agile development workflows for IoT, not only developing firmware for IoT, but taking a look at how to possibly do that in an agile way, and what it takes in terms of tool chain and tools to have an agile development workflow. And looking at development for ARM Embed, of course, I would like to show some options of how an agile development stack could possibly look like. There are several options to approach this, and we're going to look at that. This is not an intro into ARM Embed OS. You should somehow be familiar with software development and with developing firmware. But the examples that we use and that will show look really easy, and they look familiar to, say, code snippets from Arduino, so you don't have to be an ARM Embed expert. No problem there. Agile development workflow. What could be parts of an agile development workflow? At least from our perspective, there's some parts depicted here. The top row is more about people within the agile development workflow, how they work together and what's important there. Whereas the bottom row is more about technology and the day-to-day operations of crafting software. So let's go through them real quick. So first is integrated development environment, or IDE. Every developer needs one, of course. And that's the core center of development productivity. Everybody wants to have an IDE that makes him or her really productive in terms of coding and speed and having the right key map in place and stuff like that. And there are quite many options for IDEs, either from the open source world or as commercial products. But that's really important for teams to be productive. Next is code management. For teams, yeah, the Git and Mercurials of this planet, sure, you need to share your code with your colleagues, and code management becomes really, really important. Especially, we think for IoT projects where you typically do not have one team, but typically have different teams for different parts of your overall solution. Say you have a team for coding the firmware, a team for coding the gateway or the cloud solution, and if a mobile app is part of your IoT solution, then you probably have another team for doing the mobile development. And these teams have to work together, especially that's the next box here, architecture and code documentation, especially when it comes to interfaces and components that need to talk to each other. Then you need to have a really precise view about all these APIs. Otherwise, things go berserk. And the rightmost box, agile process tooling for teams. That's the world of, say, Confluence and Jira, where you can manage your tasks and your teams and the work that you have to do. So these are the some integral parts that's more related to the people working together. And the bottom row is about technology. When coding for IoT, you typically need an embedded platform management. So embedded devices, microcontrollers have different architectures, and you need some form of cross-compilers. You need special linkers and tools to flash the firmware onto the board, and you want to debug your stuff, and you need additional hardware to connect your debugger to the board. So that's all part of the embedded platform management. And although you could install all this manually, typically you don't want to, because that's boring and repetitive work. So there should be some solution that automatically installs you all the necessary bits and pieces that are part of this. So next important part is unit and end-to-end testing, which should, in our opinion, be automated. Testing, important part of embedded development as well. But you don't want to run individual tests manually and see how it goes. Somehow you want to have your unit tests run automatically every time you push something to your code repository. And that's very similar to the last box, continuous integration. So although you could run your whole toolchain on your developer desktop, typically you want to have some form of CI, continuous integration server somewhere that is able to pull your code from your repository at the latest revision, compile it using the correct toolchain, install here, and running tests. Local unit tests, and ideally flash your firmware to your device or a fleet of test devices and run test suites on these devices as well. So that's continuous integration, also very important in our opinion. So what are we going to look at in particular? For the next slides, I have a very short intro to ARM Embedded OS and Platform.io. And then I would want to leave the slides alone and go into a demo of three different things. First is the Embed Cloud IDE. That's a web-based IDE that is from ARM Embedded directly. I'm going to show that. And then we're looking at a locally installed tool chain that is the Embed CLI, the command line interface, which does the heavy lifting of compiling all your stuff and linking all that. And happens on the command line, which is another option. And the third option we would like to look at is using Platform.io in conjunction with the Embed framework and cloud service to have continuous integration into our solution. And after after that, I try myself in a short comparison of what we just saw regarding some aspects. And after that, the Q&A section. So if you have questions during the webinar, you're welcome to enter them into the chat box, and I'll give my best to answer them. Okay, let's go on with the short intro. ARM Embed. Embed is a platform for embedded software development for small devices, which are connected to the internet. So this is ideally for developing IoT-based stuff. Of course, for ARM microcontrollers, because it's from ARM, and ARM Embed OS is the operating system. Sits on top of the CMSIS and RTX, the RTOS, real-time operating system parts. And one nice thing about Embed OS is that it offers an C++ abstraction layer on top of the RTOS. So things such as interrupts, events, timers, digital in, digital out, mutex, queues, and so on and so on, are abstracted by C++ classes, which, in my opinion, makes developing for embedded easier. So that's ARM Embed OS. One other thing we're going to look at is Platform.io. The URL is platform.io.org, and it's an open source ecosystem for IoT development. And one cool thing about Platform.io is that it's truly cross-platform, both for the components that run on your desktop, runs on OS X, Windows, Linux, as well as to the underlying development platforms, the embedded platforms. And you see here 24 development platforms are supported, and a whole bunch of frameworks starting from Arduino, ARM Embed, Zimba, what have you, and a whole bunch of embedded boards are included. So all these things need to be installed, and this is one thing we're working on. It's called IORaptor. It's a curated list of tools within this IoT development space, and it gives you options to select tools that are suitable for your environment and download them automatically and automatically install them. We're going to see that later on. So let's dive into the demo. You should now see my screen. Let's check that. Yeah, you do. So that is around here is the one development board that I'm using. It's an ARM, of course, ARM Embed enabled board, and let's start with IORaptor, our own tool. You can download it from the website, and it has a bunch of categories. And for example, we could choose from toolchain management. Say we choose the ARM Embed client and Platform.io. And from the IDE side, let's take Visual Studio. And you see them here in your toolchain, and clicking here, I can download all this stuff, and it will then ask me whether I want to install it automatically, which I don't, because I already have it. So no need to say no, thank you. But that's the way to install the tools that we're talking about. So let's start with the Embed IDE, which you can see here. It's at os.embed.com/compiler. So you need to register, and then you find the navigation to this cloud IDE, and it's structured, of course, around projects within your workspace. And this is one thing that I've opened, typical view with the files that you can have here, see here also. And the cool thing about the Cloud IDE is that it allows you to really easily create new firmware programs for this. Say I set new, create new program, and I can choose the type of boards or import boards that maybe I have bought, and I'm choosing my own board here, which is the Disco L475, and so on and so on. And one nice thing about it is that it automatically grabs demo templates. So I can, for example, here choose some sort of demos that are readily available for that board. Let's say I use the LED and button control example. Okay. Now it's creating my project, and it automatically pulls in the dependency that I definitely need, which is the Mbed OS, and it generates me a main CPP from this template. And I can choose a different one now. So let's see, should work out. And it's very easy to work with. Just say compile, and it uses, of course, a cloud compiler, and compiles that single file and the Mbed OS, and automatically downloads it. So I have here in my download folder the binary, which I can directly flash onto the board. And do this. This is just by copying from downloads folder. How is the name? Disco.bin to /volumes. To plug it in again. Yeah, there it is. And did you see that? Probably it. Yeah. When flashing this, so this was a simple copy command of the binary to a mounted volume, because when you plug in the board, it automatically mounts. And when it flashes, this LED flashes red. I don't know whether you could see that. And now this small LED starts flashing. If I press the user button, I think that's the purpose of the sketch. Oh no, it flashes different LEDs. So yeah, so Sketches is working. What's really cool about the Mbed Cloud IDE is that you can, when you have bought new hardware, you can very easily try this out because of that many templates. It includes, for example, Wi-Fi server because it has a small Wi-Fi module here, and so on and so on. So that's the Cloud IDE. Another option is to, one thing I'd like to mention still is the use of libraries, because what is very easy is to pull in new libraries. You can say import library from a wizard. So you can, for example, search for a library, say an HTTP library. Search takes some time, or you can look up libraries from ARM Mbed as well. For example, SRF08 Ultrasonic Ranger. If I click here, then typically I have a button called Import Library, and if you have another tab open with your current project, then it will import this specific library into your project. Here we have the list of, well, that's many of HTTP server or client libraries. So that's also can be very easily done, importing libraries into here. So another option to code for Mbed is to use the CLI, which is, for example, at github.com, mbed CLI. I've opened up the README, and it has a section for the installation of that CLI. And For Windows, you get an automated installer. For Mac OS and Linux, you need to follow these instructions here, which go by pip. This is the Python package manager, so to say. And yeah, you need to follow some steps. And ThinkForward, we're experimenting with the Docker approach, where you can have a Docker container, which includes the embed client and as well the GCC compiler for ARM. So you have it all in place in one container. And Docker is available on Linux, Windows, and Mac OS as well. So that's really cross-platform. I can show that too. Here. So I have a Docker image that's called, no, not Docker images. Yeah, here we have it. It's the embed image, which I built from this repository because there's the Docker file here. And as you can see, size 1.6 gigabytes, quite large because that's the whole GCC ARM compiler collection in plus the ARM embed client. So that takes some space, but it's in the image and not on your local desktop machine. So it's not polluting your file system, but it is kept in the image. So, and I have a alias that lets me just use the embed tool as it is in a container. So embed version gives me back 150. Okay, but in the end, it starts a Docker container and calls the embed CLI. So what can you do with it? Typically, the flow is I'm creating a new directory, initially empty, and set embed, say embed new demo2. And then it creates a new program demo2 and adds the embed OS library from GitHub, which can take some time now because it clones the library and there are quite many files in there. So let's just fast forward to another program that I created before. So what it creates you is a Git repository and an .embed file where you can specify the target, which is my board here, and the tool chain as well. And it puts some other files here that are necessary. And the main program is rather simple. I just print out on the serial line some hello world stuff. And for example, I can say embed compile. Oh no, alias is not in there. So oops, check this alias as well. Embed compile. Okay, disable this here because it takes too long. And in this directory, I already compiled the embed OS library stuff, so this goes real fast. And I have again an image which I can copy to my board. Volumes, this then I can't see it here, but it's flashing. And yeah, so that prints stuff on serial lines. So I should be able to simply cat serial line and reset the board here. Yeah, it prints hello world every time I reset it. That's what Sketch does. So that's the embed CLI. So everything that you can do within the Cloud IDE, you can do here as well, plus many more additional things, but it's all on the command line. And the third option to demonstrate is Platform IO. Let's see, I've installed myself VS Code as an IDE, and it has a good integration with Platform Platform.io. As you can see here, there's the Platform.io home screen, where you can easily say, okay, I want to have a new project, and it lets me select the board that I have from a bunch of boards. I have 479 available, so let's search for IoT one. There it is. ST Disco L7475, and framework, embed, or cube. And yeah, with this, I could easily create a project, and Platform.io would automatically download the toolchain and the framework that is necessary to compile that sketch. Now, again, that would take too much time, so I already created a bit here. And there is the main sketch, which essentially does the same, print something on the serial line. And we can try this out. You have some additional files here. Platform.io.ini declares 2 environments, one for the board and one is a native environment, so that I'll be able to compile parts of this project on the native platform and, for example, run tests on it. And yeah, testing. If you're interested in unit testing for embedded, 2 weeks ago, we did a webinar for unit testing on embedded using Platform.io, where we go into the details of this. But for now, I can just show this to you. I'll open up a terminal here, and the short command is PIO test, because I want to run this very simple unit test, but PIO test for an environment that is the native environment. And why is my PC so slow? So as you can see here, PIO test compiles the test cases and runs the test on the native platform. But I can also PIO run for my real environment that I have declared here, that is the board. Then it will compile for the embed platform, including the embed libraries and stuff. Drops out of firmware, and I can also upload this to the board. Maybe you can see that linking. Now you can see that it's flashing here. So it yeah, uploads the same. It does the same as the embed client, but more automatically, and yeah, integrated into a nice IDE. And what I would like to show additionally is the CI integration. Platform.io has sort of built-in integration to Cloud CI services with examples already. So there's like Travis CI and Circle CI, GitLab, and that stuff. And you can even run your own, like Jenkins. That's all integrated. And I'd like to show this for Travis, because this project that I have here is located at GitHub in my own GitHub account, and I created a Travis CI integration for this. So Travis CI pulls my repository and pulls every update that it finds and automatically builds it. And how does it know how to build? If you look at the project here, there is a .travis.yaml file, and this Travis YAML file has all the details, and it says, okay, you have a Python environment, and upon the start of a new build, it installs Platform.io and updates, clones the repository, and uses essentially the same commands that I just typed here locally in my terminal. That is compile the sketch for the embedded board, run tests on the native platform, that is on Travis CI Cloud Service, and additionally it flashes what it has just compiled to my device here. And how does it do that? On my desktop, I run a Platform IO agent, which goes by this name, which is connected to the Platform IO service. And the last command here is Platform IO remote, which runs remote commands on my agent, and it uploads the sketch on my board. So every time I would make a change here and push that change to the repository, the build would run, but I could also say here, restart build. And yeah, hooray, the build was successfully restarted. And now it's going to take some time. Can I show that? Maybe it can be better seen. Now I have to follow the log. And it starts to clone the repository and do things all automatically, which is of very high value when working in teams, because software is not only compiled and tested if someone wants to compile and test, but every time someone is pushing this to a common repository. And yeah. That's essentially what's needed in an agile development process, because everyone wants to know about the status of the current build. So continuous integration, really important. So as you can see here, it compiles parts of the Embed OS firmware, and it compiles in the end my sketch. Yeah, exited with 0, so that went well. It now runs the Platform IO test command, and 1 test, 0 failures, good. And then it, well, didn't catch it, but it, can you see? Yeah, you can see it a bit here. It did flash. So the Travis CI Cloud Service did flash the firmware on my device that is connected to my notebook, or it could be connected to some local server. All works out perfectly. Okay, back to the slides. Quick comparison of what we just saw. So we compare the Cloud IDE, the locally installed CLI, and Platform IO. So looking at the ease of use, meaning how easy it is to get things going, then the Cloud IDE definitely wins, because as you saw, just select your board and start with the template and run demo code, click compile, and everything is yeah, really made easy to developers who are new to Embed. The opposite is true for the CLI. You have to know how to install the command line interface to your PC, and yeah, you have to take care about the local toolchain. Platform IO makes stuff easier again, not as easy as the Cloud IDE, but still easy enough. You have wizards for new projects. You can select boards. You have a lot of help at the Platform IO website. So that's good. The required experience level, not only in terms of development skills, but only operation skills for the Cloud IDE, super low. As you saw, it's a UI. You can just click on stuff and stuff works typically. And whereas for the CLI, you have to have some experience on how to install software on your machine and on the command line. Platform IO is somewhere in between. So when constructing build chains, you typically want to know how much control you have of everything. And looking at the Cloud IDE, you do not have that much control. Of course, when you start a build, you get the output from the compiler. So if there are any errors, you see them, of course. But it's not that you can tinker around with variables and special build constructs that you might have in your custom build chain. So the Embed Cloud IDE doesn't really allow for that. The opposite is true for the CLI, of course, because it's all locally to your machine, so you can do everything you like. So you have very good control of your build chain. Platform.io is somewhere in between. It's even good. It has a construct in between. It uses Sconce, which is a Python-based build system helper, so to say. It's a software construction tool set. And essentially, it is able to write you the make files and detect all the sources that you have and libraries and dependencies. So that's really helpful. Control of code repositories. Embed Cloud IDE there is repositories behind, and you can share your code with colleagues or make it public, which is real cool if you write libraries, because others are able to find your libraries as well as you are able to find the libraries of others, which is great, but not the same level as you would have if you, say, use GitHub or GitLab or even your own on-premise Git repository. So therefore, the Embed CLI and Platform.io allow you really more fine-grained control of the code repositories. Yeah, continuous integration, continuous deployment integration options for the Cloud IDE. As you saw, just hit the compile button and it does everything for you. So there's not really need for CI. It actually, right, as of now, I think it cannot remotely flash your firmware to your device. It doesn't have an agent for that. The Embed CLI, well, that's okay, as if you can install the Embed CLI in your CI environment, then, well, that works out perfectly well. And yeah, as you saw, Platform.io has really cool support for continuous integration, because it supports a real bunch of CI services out of the box, either on-premise or cloud-based ones. Yes, so this is about it. I hope I could give you a good overview of the options that you have when you want to get started with Embed, and yeah, give you a better feeling of which option to use regarding your requirements that you might have within your company. So thank you very much for following along, and yeah, if you have any questions, either now, put them in the chat window, or later on, no problem, just contact us, my email, our website, contact us at Twitter or by email. So if you have any questions, don't hesitate to ask. Okay, no questions so far. Took a bit longer, see, 41 minutes. Yeah, again, thank you for following along. Wish you a great day, great evening, and yeah, good fight, good night.